Okay, that was almost in unison. Thank you for that. Today we're going to talk about overlapping figures. It's very important to be able to notice in overlapping figures what the figures have in common, because a lot of times we're going to do what I call as an auxiliary drawing, and we're going to pull the figures apart to be able to discover more information about them. So for example, in this particular picture right here, I might go ahead and draw two triangles to represent the triangles that are listed at the top of the question. And so there's one triangle, and instead of drawing the second triangle, I think I'm just going to duplicate this one and flip it. So dupe, and then there should be a flip option. Transform, flip in y-axis. So now I've created two triangles, and basically what I've done is I've wanted to pull this triangle, triangle ABD, apart. So I would label the corners, and then I would want to pull triangle ACD apart. So the advantage of pulling these two triangles apart is if now I do something to find these two triangles congruent, I can now mark side BD congruent to side AC, whereas before when they were together I couldn't do that. It's also easier for me to see that this angle corresponds to that angle. But what's important is we remember what they shared. So before I pulled them apart, it was this triangle right here, triangle ABD, and it was this triangle right here, triangle DCA. Now what do those two triangles share? They share the side AD. So it's important to realize that even though now these two triangles don't overlap anymore, AD was congruent to AD by what? By reflexive. So recognizing that shapes might get pulled apart to make them a little bit clearer, but before I pulled them apart, they had something in common, and that thing still exists. It's still in common. I've just redone my drawing. By the way, I call these things right here auxiliary drawings. Drawings that are formed by pulling apart the original one to make it a little bit less complicated. Also, if I use auxiliary drawings, I need to be careful in my proof how I label things. For example, what angle does that angle look like?
C.
This looks like angle C? Yeah. Let's try again. What angle does this look like? What is that letter right there? B. B. So this, you would have a tendency to say, if I said, hey, name that angle, you would just say angle B, right? However, this angle right here represents this angle up here in the original drawing. Is angle B sufficient to describe that?
Yes.
No, it's not, because there's more than one angle at that point. So what I'm saying is use angle ABC instead of angle B to describe that angle. Because it really came from a more complicated drawing, so we need to be more specific about how we refer to that angle. Question?
Well, I was just going to say, why couldn't it be ABD?
And it absolutely should be ABD. I made a mistake. So why? Because you're smarter than me, that's why. Yep. Oh, man. Now I can't even write. Look at how flustered you've gotten me. A, B, D. So yeah, ABD refers to this angle right here. ABD still refers to that angle right there. So when you're labeling things in an auxiliary drawing, you probably need to be a little bit more specific with your labeling than you normally are. So what would we call this angle right here? Yeah, so we would use angle ACD instead of angle C.
Whoa.
I don't know what's going on here. I'm having some glitch issues, so I know. angle C for this right here. All right, does everybody understand that concept about how to pull things apart to get auxiliary drawings?
I don't, so B and C are congruent, or angle ABD is congruent to ACD.
Well, I mean, I started marking things like they were congruent. Really, this is all given information because we're not really doing a proof at this point. So the only thing you're sure about is AD is congruent to AD by reflexive. That is, it should be obvious by examining the drawing. Everything else I was just kind of throwing in there to illustrate stuff. All right. All right, so what I want to do here, is I want to solve this proof. And the concept behind this proof is going to be the fact that we're using some overlapping triangles. Now, there's a couple of different ways to do this proof. I'm going to go with the shortest, quickest, easiest way. Sometimes it's good to be able to look at a proof and kind of analyze where you're going. So what I'm trying to do here, the goal of this proof, or the proof statement, is that we prove that the green line is congruent to the yellow line. And we start out knowing that this whole big old triangle over here is congruent to this whole big old triangle over here. So I think maybe the first thing I might want to do is I might want to make some auxiliary drawings. And yeah, I heard somebody yell CPCTC, so that's probably going to be a clue in how to handle this proof. So I'll go ahead and do the, oops, I don't want to move that around. I'll go ahead and do the two drawings, dupe it, and then flip it. Move it over. So you can kind of see how the triangles will be overlapping, and you can just kind of pull them apart. I kind of tilted my triangle a little bit. My apologies. So this is A, C, D, and then here's the D, and here's the, no, here's the C, and here's the D, here's the B. All right. So how do I get these two lines to be congruent? One of the first things my eye sees, and I think this is basically because we've just been working with this in section 4.5, but triangle CED would be an isosceles triangle if the green and the yellow line were congruent. So if I can prove that angle BCD is congruent to angle ADC, then I can prove that those two lines are congruent by the converse of the isosceles triangle theorem. That's where my eye went. Another person might be saying, oh, well, if I can prove this small triangle over here, AEC, congruent to this small triangle over here, BED, then I can prove that the two sides are congruent by CPCTC. So there's two ways to go about approaching this. I'm just going to go with what I saw first. So the first thing I'm going to do is write down the given information, of course. And the given information is that triangle ACD is congruent to triangle BDC. And that's really nice that they've given us two congruent triangles. Because now I can jump in, and after I've pulled them apart, to me it's really easy to see what the corresponding parts are. So now that I know that these two triangles are congruent, it's kind of easy for me to pick out that this angle is corresponding to this angle. Well, this angle is angle ADC. And remember, I told you I was going to use three letters to write it. To be a little bit more specific, I forgot to put the angle symbol first. Angle ADC, and then that would be congruent to angle BCD. So I'm not even going to use the fact that they had overlapping information. I'm just going to mark this angle congruent to this angle. I could say that CD is congruent to CD by reflexive, but I don't need to. Because once I know that these two angles are congruent, then I can use the converse of the isosceles triangle theorem to state my proof statement. So now CE is congruent to DE by the converse of the isosceles triangle theorem. So this turned out to be a really short 3-step proof if I went about it the right way. So to recap, the way that I figured that out is I looked at what I needed to prove, and then I kind of worked backwards from there. Okay, well, if I know that those two line segments need to be congruent, what else do I need to know? And I came up with, oh, wait, if these two line segments are congruent, this is an isosceles triangle. So if I can just get these two angles congruent, then I'm okay. Pull the drawings apart and notice that those two angles were the corresponding parts. So since the triangles were congruent, by CP/CTC these angles were congruent, then I remarked them on my main drawing, and it was really obvious that now this was definitely an isosceles triangle. By the converse of the isosceles triangle theorem, I could say that the two sides are congruent. So really knowing what your theorems are and knowing how everything fits together, being able to think about things, work things backwards, pull drawings apart, these are all skill sets that develop your critical thinking and will help you as you learn to do more complex proofs.